Let's take a look at the 2007 free response for number 4 on AB and also BC. It is the same for both of them, and so here goes. A particle moves along the x-axis with position at time t given by that formula right there, that function, and this applies between 0 and 2 pi. I'm going to write it just because it's fun and worth writing. So f of x, whoops, not f of x, not at all f of x. It's traveling along the x-axis, so its position is x of t, and that is e to the negative t sine t, and that applies from 0 to 2 pi. So here goes. Let's start with part A. I wrote it. That's a waste of time if you're taking the exam, but I did it because I'm going to be pointing and using it. So find the time t at which the particle is farthest to the left. Justify your answer. Okay, so what we're finding is an extreme value, right? We're finding when it is farthest to the left. So we're looking for the leftmost point. Now, we can't test every possible point between 0 and 2 pi. There are an infinite number of them. But what we can do is use our knowledge of maximums and minimums. This is a minimum. I mean, it's kind of sideways from our perception, but it's a minimum. So we're going to use the extreme value theorem, which basically says maximums and minimums occur where the derivative equals 0 or at the endpoints of an interval. So what I'm going to do for this one is test it using a few points that I have. I need to find my answer key to this so I will know how to grade it and how to tell you. There we go. I found it. All right, so here goes. Sorry, I was thinking, how am I going to tell them what they're looking for? We will test t equals 0 and t equals 2 pi. Now we're doing that because we need to test the endpoints of the interval. Well, where else do we test? Well, we test where the derivative equals 0. And so we're also going to, I'm just going to scribble this up here. We're going to find the derivative and set that equal to 0. And we'll go from there. So x prime of t equals, well, let's see, product rule, don't overlook that. So f prime, there was a chain involved in that, f prime g plus f g prime. And what I'm going to do for the purposes of part A is set this equal to 0. And when we do, there we go. This was some scribbling that goes with part A, but I didn't put it under part A. But whatever, it's there. What I want to do is factor out that e to the negative t. And when I do, I have negative sine t plus cosine t, looks like cost, equals 0. And we'll set each factor equal to 0. So there's this one. And there's this one. And there's nothing that's going to happen with this. So if you were to solve it, you'd say the natural log of 0 equals negative t. And yeah, good luck with that, because that's no, just no. So that's not true. You'll get, I'm trying to mark out the equal sign. You'll get nothing from that. But on this side, you can set those equal to each other. So cosine of t is equal to sine of t. And I need to know where cosine equals sine. Well, cosine equals sine on the unit circle. Here, I'm about to lie to you. Here, 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 and here. Well, actually not here and here. So it's 45 degrees. Let's actually call that what it is. That's pi over 4. And it's not here because this is where they're all positive. This is where sine is positive and cosine is negative. So no. This is where sine and cosine are both negative. So this works. This is 5 pi over 4. And then this one does not, because cosine is positive and sine is negative. So when I solve this in my head, because you can do it because you know the unit circle, I hope, I get that. Okay, so we're going to test that, and because of this, we're also going to test pi over 4 and 5 pi over 4. And what am I testing? Like, what am I going to find? Well, I'm looking to see where it is the furthest to the left. So I'm going to, well, do t and then x of t. And we'll try 0. We'll go in order here. We'll try pi over 4. We'll try 5 pi over 4. Well, I'm taking up a lot of space with just part A, aren't I? Good thing there's only 2 parts. And then we're going to plug those in and see what we get. So let's do that. When I plug in a 0 right here, I have e to the negative 0 times sine of 0. Well, sine of 0 is 0, so 0. So far, that one's the furthest to the left. So here I have e to the negative pi over 4 sine of pi over 4. And then you get into some craziness, but that's okay. This is actually 1 over e to the pi over 4, if you want to start rearranging things. And then sine of pi over 4 is square root of 2 over 2. And you can simplify that a little bit. I choose not to for reasons that'll become obvious in just a second. So let's do this one. E to the negative 5 pi over 4 times sine of 5 pi over 4. And so I have 1 over e to the 5 pi over 4 times, oh, what's the sine of 5 pi over 4? It's negative square root of 2 over 2. Okay, so we have a positive times a negative now. So this one is negative. So far, this one is furthest to the left. And if we plugged in 2 pi, we'd have e to the 2 pi times sine of 2 pi, which is still, well, 0. Okay, so which one is furthest to the left? That would be this guy right here, because it is less than 0. All right, so let's make sure we've answered the question. Find the time t at which the particle is furthest to the left. Justify your answer. Now, just doing that isn't enough. So the particle is farthest. It's a grammatical thing, isn't it? Farthest is the way they worded it. Farthest. Here we go. We're going to get it right here. To the left. I forgot how to write between here and here. It just was a mess. At t equals 5 pi over 4. And when they said justify your answer, I think we have. I believe we've justified that because we talked about what we're going to test. We set our derivative equal to 0. And so I am going to, well, should I clarify any further? I think I will. If we have time, we will. So, nah, we're good. We're good. Here goes. Answer key. We need to find the derivative. We get 2 points for that. So here we go. 2 points for that. We need to set that equal to 0. So we got a point for that. And we have our answer. And now let's dig a little deeper into what's going on here. And then our justification. So x prime equals 0 and cosine t equals sine t. We did that. Therefore, x prime 0 on that. And then, okay, so the candidates for absolute minimum are 0, pi over 4, 5 pi over 4, and 2 pi. So all the logic that we have here was spelled out in our work, or even explicitly here. And so we had a justification, and so the last point is the justification, which I think is all this right here. Some of it kind of happened right there. All right, so we have just earned 5 points. Let's earn 4 more. Now, part B is a little bit trickier. We'll set the answer key aside, and let's look at part B. I promise I'm not looking at the answer key. I turned it over. Find the value of the constant a for which x of t satisfies that equation between 0 and 2 pi. Whoa, what in the world are we talking about here? Okay, so I need the original, got it. I need the derivative, got it. And I need the second derivative, which I don't have. Okay, so x double prime of t is, okay, well, what I'm going to do is find the second derivative, and for that I need my first derivative, and just so I'm not doing this the whole time, I will waste a couple minutes, and, well, a couple seconds, and rewrite it. Sine t plus e to the negative t cosine t. All right, let's come over here, and let's find the second derivative. And when we do, we're going to have to do the product rule here and the product rule here with the chain rule there and a chain rule there, and a lot of that happens in our head, so don't panic. Here goes. F prime, which would be this because we multiply by -1 with that -1, so F prime g plus F g prime. All right, that took care of this term. Now let's go to this one. So F prime, chain rule, g plus F g prime, the derivative of cosine is negative sine. And before we get too much further, we realize what's actually happened. So we found the second derivative, and this term cancel out, and these two go together. So the second derivative is -2e to the negative t cosine of t. All right, now let's really answer the question. I went to the wrong problem. X double prime plus x prime plus x equals 0. We can solve this thing for a. It's going to be pretty easy. So a times the second derivative, so -2e to the negative t cosine t, plus the derivative, so -e to the negative t sine t plus e to the negative t cosine t. That plus negative's bugging me. We're in calculus now, we don't need it. And then plus the original, which was e to the negative t sine t equals 0. And we want to find out what a is. And actually, it's going to be pretty straightforward because, once again, we have a couple things that cancel. This one and this one cancel out. And so we are left with negative 2a e to the negative t cosine t plus e to the negative t cosine t equals 0. So basically, I need these two things to cancel out. I want them to be the same. So if you want to look at it this way, and you don't have to, and I don't recommend you like go this far in your work and like pretend like it's all the same problem, but here's one way of looking at it. Negative 2a times something plus something equals 0. And those two somethings, it better be the same thing. So like if you're going to solve this thing for a, you'd have negative 2ax equals negative 1x. And then you would divide by negative 2x. And so the x's cancel, and you get 1/2. So a equals 1/2, which kind of makes sense. Like negative 2 times 1/2 is going to give me negative 1 plus that 1. You could probably think about it that way as well. So let's see what the breakdown was. We get 2 points for finding the second derivative. Lucky us, so there we go. And it did simplify to that, so we can do that. And then substituting all of those things into that formula they gave us, that was worth a point. And then our final answer was worth another point.